Hello, students, and good morning to all. Welcome to Byju's. So, this is Basavaraj here. So, I'll be taking ecology and environment for this batch. Hope I am audible as well as visible to you all. We'll wait for a minute and then we'll start with the session. Okay. So, I think you might have completed your geography part, right? So, basics of geography are also important here. And when we talk about this ecology and environment, now, why it is important in the prelims and what type of preparation is required here. Now, when you take up the exams in the prelims, you can expect around 10 to 15 questions from this. 10 to 15 questions in prelims. In the mains, you can expect around 1 to 2 questions. In fact, you should not surprise if 3 questions are there. So, mains also you will find the questions here 1 to 2. And sometimes the environmental part is concerned with the geography part. So, hence, clubbing is done between geography question and linked with environmental part, right? So there will be a case where one question will be asked linking with environmental concern. Say, write a note on the geological evolution of Himalayas and what are the major environmental issues associated with the Himalayas. Or sometimes they may ask a question, a very general question: what is the impact of climate change on Indian agriculture? Or sometimes they may ask a question: what are cyclones? And write a note on the impact of climate change or global warming on the cyclones. So there will be a merging of geography linked with the environmental perspectives are seen. So it should not surprise if more than 2 questions appears in your mains examination. Is it clear? So this is one thing. Then coming back to make an approach here. Now, first, you should understand what to study before moving down to this. First, you should understand what to study. Then, what means it is syllabus. In a rough way, we can say it is a syllabus. First, you should know the syllabus of the topics or syllabus of the subject. Then, how to make the approach, that is strategy. Strategy. First is to know that what is content, that is the scope of the subject. And this you can get it by reading previous year question papers, analyzing them. You will have an idea that what exactly is required in the context of examination. Then the strategies. No, here strategies, when we say, it varies from person to person, individual to individual, because all human beings, when we say, their capturing capacities vary. Some are from humanities background, some are from science background. So hence there will be variation in the understanding of the topics. So it's not about the time, it's about understanding of the topic is important here. How much time you spend is not important. What you are absorbing from that, what you are understanding from that, what way you can put them into your answers. So that is very, very important. Rather than time, your understanding matters much in such subjects, right? So every students will have their own strategy. We'll discuss some part of that. Every student will have their own strategy. And the third perspective is that whatever strategy you are having, you should always make a revision. You should always make a revision. Now, revision in the sense, along with reading, you should practice more writing. Along with your reading, you should practice more writing. Keep this in the mind, because 10 times reading is equals to 1 time writing. The more you write, the more confidence you will get in the topic or in the subject. So whenever when you're making the writing aspects there, you should remember that whatever content you are delivering here, it is always updated. It is always updated. Updated in the sense, we are talking about current affairs, updating with your current affairs. Right. Writing in the sense, whatever topic you are reading, make notes on that. Writing refers to notes. You should always make notes on that. Current affairs. For example, if you are reading, say, agriculture aspect. Now, in the context of India's agriculture, Indian agriculture is something which is affected by the impact of global warming as well as climate change. Now, I'm using two words. One is global warming and second one is climate change. So when I take the topic, I'll explain that in detail. What is global warming and what is climate change? In geography, you might have studied the difference between weather and climate. So I'm referring to the same phenomenon, climate change and global warming. Now, the impact of that is seen in Indian agriculture. Now, in that case, we always make some contribution of science and technology in all the sectors, including agriculture sectors. Now, in the current affairs, you should make updation of what technology has been introduced in the context of agriculture in the purview of climate change. Example, precision farming. We are talking about organic farming. We are talking about something called as climate smart agriculture. So these things you should be updating here. I'm just giving an example. When you're talking about agriculture, you should understand what is the agriculture perspectives in India and updations on that, various schemes and various technologies. Various schemes and various technologies. They should be updated. And once you update that, then your answer becomes very clear cut, and that will help you to write a very best way forward or conclusion to your answers. So here you should always understand what is syllabus. Second, the strategies has to be developed by your own assessment. You should assess yourself that in which particular topic what time I should spend, whether you're understanding that or whether that content you are able to digest or it is taking more time to that. First you assess yourself, and based on that you make the strategies. And then revision is associated with writing capacities. You should write them 1 time, 2 times, 3 times, any concepts, the keywords, then it becomes easy for you to remember them for a longer period of the time. And that should always be updated. That should always be updated. See, when we talk about the replicating points, there are something called as keywords. So the moment when you put the keywords in your concepts, so those keywords, if you revise them 1 times, 2 times, it will always be there with you. Try to put them in your flow charts. Try to put them in flow charts. Or use diagrams. Use diagrams. So when we use these perspectives, then it becomes easy for you to understand the flow. Is it clear? So this is some rough idea about the prelims and mains perspective and how to move ahead. Now next is, what is the syllabus of that? Why we have to read that? And what is the scope of the subject here? Now when we talk about such perspectives, you should understand a simple part of this. At present, we know that the urbanization is unplanned. Unplanned urbanization. Urbanization is there. Second, population is also increasing at very high rate. So we say rapid increase in the population. rapid increase in population. Third one is when we talk about industries, so rapid industrialization has taken place. Rapid industrialization. Industrialization. So because of all these, unplanned urbanization, rapid increase in the population, rapid industrialization. So whatever resources which we are using, it can be natural resources or it can be man-made resources. So they are making huge impact on the resources. And that is where we say over exploitation of resources is being done here. It is responsible for over exploitation of resources. It means we are using them more than what they can be replenished. We are using more than what they can be reoccurred. So hence, we are always making over exploitation of resources. And because of this over exploitation of resources, the resources will become degraded or they will become depletion. So which will lead to degradation of resources. And the moment when the degradation occurs, then we will have many type of issues. So this degradation will create many issues. It can be pollution, like air pollution, water pollution, land pollution, etc. Or when we are using the land loses its fertility because of over exploitation. So we refer that as land degradation. Land degradation. Along with that, we also find the issues like global warming and climate change. And also we find many impacts are there. It can be cold waves, heat waves, etc. So the degradation of the resources will lead to such issues: pollution, land degradation, deforestation, cutting up of the forests, which can lead to decreasing in the forest cover areas. So many such issues will be seen, which again impact the human tendencies. So hence it is important to understand that what are these resources and what is the state of their resources, what is their present state, whether they are in good state or whether they have entered into bad state. So we have to assess their state. We have to make an assessment of their state. Take an example of forest. What is the state of forest? Air. What is the quality of air we are breathing? Water. What is the quality of water which is there? So all these things we have to make an assessment. Then after that, once you assess that, what is the impact of degraded resources on human society? After assessing, you have to make the impact of that. How it is affecting our GDP, how it is affecting human health, how it is affecting other sectors. So this had to be kept in the mind. Now, once you understand the resources, their present state, and their impact, then the next aspect is how to bring them back into normal path. It means what is the solution for the issues. Next is the solution for the issues. Solution. Now, this solution can be given in two ways: national ways and international ways. So the solution can be national approach, and second is international approach. Right. So what are national approaches? National approaches, the moment when you say, you have to remember that national approaches talks about national policies, acts, etc. Policies, Act, etc. But how we protect them with legal acts like Wildlife Act 1972, Forest Conservation Acts, policies, environmental policies, so that we can bring them back into normal, or we can find a solution for the present scenarios. Now, what are the international perspectives? In the international perspectives, we come across many organizations or institutions. We come across many institutions. We also come across many agreements, like generally we refer them as conventions, protocols, etc. So these conventions, protocols, etc. are very important to make an effort in understanding what is the international approach to the issues of such perspectives. So we have to make mix of that: national approach, international approach. Like when you talk about, say, deforestation or forest issues, we have international approaches are there. We have national forest programmings are also there. When you talk about any pollution issues, national approach and international conventions are there. So they will help us to understand and assess the condition and how to reduce them, so that the life become somewhat better compared to the present scenarios. So that is where we have to make sure that when you are reading the environmental or ecology and environment subject for your UPSC, you should understand that what way the urbanization, population, and industrialization has affected the resources. Resources means anything which provides economic benefit. It can be land resource, it can be water resource, it can be air what we breathe, it can be forest resource. So all these we refer them as resources, anything which provide economic benefit. Economic benefit, right? So anything which provides economic benefit, we refer them as resources, right? Now, due to over exploitation, why the over exploitation has done, what are the reasons for over exploitation? So you have to make an assessment of that. Then this has led to degradation of resources. Now it can be pollution, land degradation, soil erosion, all these we have to make. Now present state of that, now how to get the present state? By reading the reports, by reading the reports, right? Reports means reports which are given by prominent institutes. Take an example of IPCC, Intergovernmental Panel on Climate Change, or the reports which are given by the conventions, emission gap report, right? So many such reports are very, very valid in the context of assessing the state of the present part, and also what should be done, what should be the course of action in the context of finding the solution for them. This is what you are to be keeping in the mind. So whenever you are making any notes, understand this aspect. Some brief introduction about that with the geographical background, and then you should talk about how it is affected by over exploitation and what is over exploitation in that resources, and then find a solution: national approach, international approach. And here you should remember what institutes provides what type of basic supports to that, whether it is legal context or whether it is talking about something which is with the form of policies there. So this is what you should keep in the mind. Is it clear? Okay. So body, like we can say CAMPA is there. So CAMPA is something which talks about afforestation funds, right? So when I take that forest perspectives, we will read them. Always link them with your current affairs. For example, if you are making any big project in the forest areas, then there is something called as compensatory afforestation fund. Now this CAMPA provides a provision for that. See, here you should always remember that to sustain humanity, we need sustainable development, and sustainable development is something where you don't have to compromise your economic growth, and economic growth is something which is required in all the stages of the development, and that is where industries, projects, all are important. Now, sometimes when you are putting your projects, say, in the forest areas, then you can't neglect that. You can't rule out setting up of that project. So in this regard, we have some process, and based on that process, there is an arrangement which is being done, and that arrangement is financial arrangement and how to go ahead with that. So that is where we talk about compensatory afforestation. That is, if you are utilizing 10 acres of land in the forest areas, so you should compensate something to that, and that is where we talk about CAMPA, compensatory afforestation funds. We'll discuss that in detail, but this is how you should make a flow. Always link that with your current affairs, right? Then when we talk about these topics, we'll take up them. Don't worry, what is sustainable development, all I'll take up when I take the topics there. Just understand the flow. So when I take development, we will talk about sustainable development also. So we'll take up all these in the purview of UPSC and in the common layman's language. Yes, Nicobar, Great Nicobar project. So Great Nicobar project, it is a sensitive area, and we should understand some social issues associated with that also. So hence, whenever when you are reading that, you should balance that economic development, environmental concern. If both are satisfied, then we say it is sustainable development. Always remember that economic development and environmental concern, both are the two faces of the same coin. I'm repeating, economic development and environmental concerns, they are the two faces of the same coin. And hence, whenever when you are making any type of economic projects, economic development, you should always make sure that the environmental conditions are sustained, environment is not destroyed. So hence we introduced a concept of sustainability. We'll discuss that later, but always you should start with these type of small introductions, like environment and economic development are two faces of the same coin. So in this context, nobody wants to be stay behind in the present world. So hence there should be a great concern on economic development along with environmental protection. So that's why this environmental has taken major stand in the present studies, right? Okay. Now, from where you have to make your notes and all. So whenever when we talk about the notes, you can refer to the PPTs. PPTs will help you in taking the basics, making the linkages. Plus, plus you can depend on the magazines like Down to Earth magazine and Geography and You. You can depend on these magazines, Geography and You, Down to Earth magazine. And then NCRT Biology 12th book, last 4 chapters. Class 12th Biology book, last 4 chapters, where they will give some basic idea about the environment and ecological studies. Some rough idea they will give, right? Along with these, you should always read the reports which are released by important institutes, like emission gap report, reports released by FAO, Food and Agriculture Organization, reports released by NASA, reports released by NOAA, that is National Oceanic and Atmospheric Administration, reports released by premier institutions of India, report introduced by any ministries. So these reports are very, very important, right? So you should always make the summary of reports and points of that, summaries and points of that, not in detail, say 7 points, 8 points with the data, and that data is important for your prelims. That data is very important for your prelims, right? So this will give you facts, right? So this is how you should keep it as simple as possible. Keep the PPTs as your background, then read Geography and You, then read Down to Earth magazine, then read NCRT books, class 12th book, and then always update that with your current affairs. Always update with your current affairs, right? Now, when you're making notes, you should remember that facts are important, concept is important. Concepts, like when we say, when you're reading any topic, say, for example, you are reading something on global warming. So what is the concept associated with greenhouse? So you come across many concepts there. So you should be knowing those concepts, right? So after the concepts, applications of that, how you apply that concept on day-to-day activities, application of that. Then examples, examples. So this is how you should make there. Now, facts you should collect from textbooks, you should collect from reports and indices. Many indexes will be there. So you should collect from these things. And then concept, you should link that with your geography part, current affairs, and also the present scenarios. So by that, you can have a good flow of your any topic for that matter, any topic for that part. Is it clear? Yes, you can read that with annotations. You can read with that annotations, and wherever when you find any, see, for example, in the context of examination, I'm just giving an example. We have more than 100 national parks. In fact, 107 national parks are there. Now, as a human tendency, you can't remember all the 107 national parks. More than 50 tiger reserves are there. 18 biosphere reserves are there. Now, you can't by heart them in which state, which type of animals are there. But we can make a data of last 1 year current affairs or 1.5 years current affairs, that which national park, which wildlife sanctuary, which biosphere reserve was in the news, maybe for any reason. Now take an example. In the present context of global warming, we find that the tigers are reaching to the greater altitudes. Now that national park where the tiger was seen, where the presence of tiger was recorded at the highest feet, say 10,000 feet, which is unusual. So such national parks, such tiger reserves will be asked in the examination, in which state and which is that tiger reserve. Now sometimes there are certain national parks, certain tiger reserves which are linked with the international boundaries, where we find certain movement aspects are there. So they are important in the context of your current affairs, right? So you should remember those national parks, those biosphere reserves, those wildlife sanctuaries which are there in the news for 1 year or 1.5 years, maybe for any reasons. So you should remember that. And along with that, we also have the census, tiger census. Now, the data of tiger census can be used in the context of prelims examination, in which tiger reserves the number of tigers have increased. Now, in which tiger reserves the number of tigers have been zero. Take an example of Dampa Tiger Reserve, which has been zero. Now we find Corbett Tiger Reserve, where the density of tiger has been increased. We come across certain states where the number of tigers have been increased. So such data which are released by the reports or the census are important. So when I take the biodiversity of India, we'll discuss that. We will discuss that, right? So this you should remember in the mind. So this is where if you go with the process in a very simple light, then it becomes interesting and you can remember a lot in the context of your ecology and environment. And moreover, here you will find many factual based questions. So keep a eye always on the map. Keep an eye always on the map, Indian map. So you can see one day you can read entire northeastern part. You can read the northern part. You can read the western part. Then you can move on to the southern parts. Then you can move on to the central India. Don't make all clubbed in one stretch. Read them separately. Northeastern parts, northern parts, western parts, then the peninsular parts. So that will help you to understand which national parks are there in the context. The moment if any national park is there in the news, you link that with the map. So by that, you can read the content and you can make sure that some questions which are seen, you can neglect by taking the consideration of objectives as well also. Right. So we refer that as elimination aspect. right? So keeping these things in the mind, we can start or will start the ecology and environment, right? Now, the moment when we talk about ecology and environment, this ecology and environment is always associated with geography, current affairs, science and technology. So hence all the basics of SNT, basics of geography are very, very important in this context. I'm not talking in detail. Basics are very important, right? Now, in geography, you are studied in detail about the landforms, rocks, mountains, evolution of landforms. All these you have studied in geography, and that makes the first sphere of the earth called as lithosphere. We refer that as lithosphere. In geomorphology, you have studied that how the landforms are formed, how the evolution of Himalayas are there, what are the different soils, characteristics of the soils, characteristics of the rocks. You have studied that. That is lithosphere. So, geomorphology part. After completion of geomorphology, you studied something which is about the Earth's surface, weather, climate, composition of atmosphere, which gases are there, how it has been changed, different fundamentals of climatology like temperature, pressures, variation of temperature, variation of pressure, winds, different types of winds. Along with that, phenomena like cyclones, cloud burstings. So all these you have studied in the second sphere of the earth called as the atmosphere. Generally, climatology, what we refer that. And the third one is about the oceans, salinity, density, temperature, ocean currents, waves, characteristics of ocean boundaries. So all these you have studied in the third sphere of the earth called as hydrosphere. So we refer them as the three spheres of the earth: lithosphere, atmosphere, and hydrosphere. Now the small area where they interact, the small area where they interact, where they meet, where the three spheres meet. So that is an area, a small area, where there is possibility of existence of a life. Possibility of life existence. And hence, this small area where there is possibility of life is there, we refer that as the fourth sphere of the earth called as biosphere. Is referred as fourth sphere of the earth called as biosphere. Right. So in geography, you have read about the four spheres of the earth, that is lithosphere, atmosphere, hydrosphere, and the biosphere, which is the fourth sphere. Along with that, you might have also read about one more sphere on the earth where the temperature is very low, and that area is always covered by ice, like Arctic, Greenland, Himalayan tops, Alps mountains, Antarctic, etc. So these areas where we find the temperature is very low and it is always covered by the ice. And that is what referred as the fifth sphere of the earth called as cryosphere. So when I take climatology, I'll explain that in detail. Right. So here remember, there are five spheres of the earth: litho, atmosphere, hydrosphere. Biosphere is a region where the possibility of life is there. And the fifth sphere is cryosphere. And that is where the entire area is covered by thick ice. And we will discuss that in detail when I take global warming and climatology. Just keep that in the mind that there is a fifth sphere of the earth which is referred as cryo. Cryo means low temperature, less temperature, right? Five spheres. Now, Here we are talking about the fourth sphere of the earth called as biosphere, where there is possibility of life. So we'll make an effort in understanding in detail about the biosphere. Now remember that the impact of atmosphere is there on biosphere. The impact of lithosphere is there on biosphere. The impact of hydrosphere is there on biosphere. So hence the basics of all the geography are relevant in studying the biosphere. So that's why I told that basics of geographies are important in the context of ecology. Right. Now biosphere. Now what is this biosphere consist of? This biosphere consists of both living as well as non-living components. This biosphere consists of living and non-living components. Generally, we refer them as biotic components and abiotic components. Biotic components and abiotic components. Right. So biotic and abiotic components. Now, what are biotic components? Biotic components, generally we refer them as plants and animals, that is flora and fauna. I'm giving a rough idea. So biotic components, which includes flora and fauna, that is plants and animals. Right. So biosphere consists of the biotic components and abiotic components. And always remember, the physical space in which these biotic and abiotic components are there, we refer that as environment. So their physical space. So their physical space, the physical space where these living and non-living components are there, we refer that as environment. So it is a physical space which is surrounding them. So it's something like this. When you visit a cricket stadium, they say the environment is energetic. It means that the region around you where they shout with more noises. So we say it is noisy environment. The moment when you enter into the temples, they say the environment is peaceful. The environment is peaceful. It means that you are moved from cricket ground where the environment was noisy. From there, you are entered into temple where the physical space surrounding you is peaceful. So the physical area, the space surrounding which are referred as environment. So environment is a physical space surrounding the biotic and abiotic components. Is it clear? Physical space. Now these living organisms and non-living organisms, they always make an interaction. They always make an interaction. Right. Now, what is the interaction we are talking about? So when two peoples are interacting, they always exchange their views. So I am interacting with you, so I'm exchanging the views. So here interaction means we are talking about exchange. Exchange. Human interactions exchange the values. Human interaction exchange food, etc. Interaction means exchange. Now what exchange we are talking in the context of biosphere? It is exchange of matter and energy. Exchange of matter and energy. Matter means nutrients. Nutrients. So in the biosphere, the living components interact with each other along with their abiotic components. I'm repeating. In the biosphere, the living components, that is plants and animals, interact with each other. They exchange energy with each other, exchange matter with each other, and also with the abiotic components, that is the land, the water, etc. So this interaction is very significant, and this interaction, which is in the context of matter and energy is to be studied. And the systematic study of this interaction, that is exchange of energy and matter, is referred as ecology. I hope it is clear now. So what is ecology? Ecology is a systematic study of interaction. Interaction means exchange of matter and energy. Where? In the biosphere, in their physical space called as environment, within the living components and also with the non-living components. We refer that as ecology, right? So non-living components means abiotic components, that is rocks, soils, water, air. We refer them as abiotic components. So the systematic study is referred as ecology. Is it clear? Now, difference between environment and biosphere. Remember, biosphere is a larger area, right? The physical space surrounding that, we refer that as environment. See, when I'm giving an example, say a cricket stadium, so that is where the larger area filled with the crowds, the physical space surrounding you is referred as the environment. In the same way, the physical space surrounding in that particular patch of biosphere, we refer that as environment. So within the biosphere, we are having environment, the physical space where the living and non-living components are there, right? Biotic factors, yes, bacteria and all. I'm giving you some example. Flora and fauna, bacteria, plants, grasses, animals, human beings, all these are referred as living components. So biotic and abiotic components. Okay, now I told that ecology is the systematic study of the interaction. Ecology is the systematic study of interaction, that is exchange of matter and energy. So ecology is the systematic study of interaction or exchange of matter and energy. Where? In the biosphere. In the biosphere. Now, biosphere is very large area. Right? So hence it is difficult to read biosphere at one stage. So we'll make a study of smaller units of that, sample units of that. So in ecology, we use a smaller unit of study. Smaller unit for the study. And this smaller unit, which is used to study, what study? The relationship between the biotic and abiotic component with reference to exchange of energy and matter. Right? A smaller unit which is used to study is generally referred as ecosystem. And hence we say ecosystem is a functional unit of biosphere. Ecosystem is a functional unit of biosphere. Functional unit of biosphere. So remember this. Ecosystem is a functional unit of biosphere. Is it clear? And in the context of ecology, we take them separately. Take an example of forest, take an example of pond, etc. So we study the ponds, the characteristics of ponds, how the biotic and abiotic components exchange their matter and energy. So this systematic study is referred as ecology. An entire biosphere can't be studied at one stage. So we make a unit of that simplified approach in the study. And that smaller unit, which is kept as a reference for the study of interaction, is referred as ecosystem. We refer that as ecosystem. So ecosystem is referred as functional unit of biosphere, which is used for the reference of the studies. Is it clear? Okay. Yes, ecosystem has its own environment. The ecosystem and its surrounding area is referred as environment. Right. Don't worry. So all these niche and all we will discuss. Focus on the flow. Focus on flow. All the topics will be covered here. Right. Okay. Now, when we talk about the ecosystems, understand that there are always three type of systems which are taken for the references. Take the example. If you are having a cup of a tea, and you are poured tea in that. After half an hour, we find that the volume of tea remains the same, but the tea which was hot has become cold. So it means that this cup of a tea has exchanged its energy with the surrounding area, but the volume has remained the same. It has exchanged the energy. It has exchanged the energy, but not the matter. The volume has remained the same, but not matter. Not matter. So such type of systems where we find that only the energy is exchanged, but not the matter. We refer them as, see this, exchange of energy and exchange of matter with the surrounding. Now, here we find that it is exchanging the energy with the surrounding, but not the matter. And we refer that as closed system. So this is an example of closed system. So in the closed system, only the energy is exchanged with the surroundings. The temperature, the hot tea has become cold. So we refer all them as the closed system. Now take another example. We are having a thermoflask or thermos, what we say. In the thermos, you are poured a tea. After 1 hour, the temperature of the tea will remain the same. And the volume of tea will also be the same. So there is neither the exchange of energy nor the exchange of matter is seen. And such type of systems, we refer them as isolated system, where we find there is no exchange of energy and there is no exchange of matter. We refer that as isolated system. No energy and no matter is exchanged. Isolated systems. But in the context of ecosystem, we always find the energy is exchanged with different organisms and the surrounding environment. And the matters are also exchanged. Nutrients, what we refer them as nitrogen cycle, phosphorus cycles, where we find exchange of matter is there. So this you already read. Nitrogen cycle, phosphorus cycle, carbon cycle, where the nutrients are exchanged. So in the context of ecosystem, we always find that there is always an exchange of energy. Energy is exchanged with the surrounding, and also the matter is exchanged with the surrounding. Both are exchanged. So energy is also exchanged and matter is also exchanged with the surrounding. And hence, ecosystems are referred as open systems. Ecosystems are referred as open systems. Right. So what is the meaning of open system? Open systems are those systems where there is an exchange of matter and energy with the surrounding environment or with the surrounding. We refer that as open system. So ecosystem is open system. Very important point. Now, second one is the size of ecosystem. The size of ecosystem. Now, size is also not fixed. When you are taking a sample area, it can be a pond size. It can be a pond, which is very smaller. Or it can be an agricultural field. Or it can be a big forest like Amazon forest or Amazon forest, which is spread in many countries. Himalayas, Himalayan studies. So all these, when we make references of the studies, we don't consider their sizes. They can be very small, like a pond or the garden besides your homes or the Amazon forest. So size is not fixed. Size is not fixed. Not fixed. They can be very small to very large, like Amazon forest, which is spread in many countries. Size is not fixed. Then energy, the exchange of energy. The time of exchange of energy is also not fixed. We don't know how long we stay. We don't know how long a particular plant species survive. We don't know how long that animal will survive. So till it survives, it always exchanges its energy with the surrounding. So the exchange of energy can be a single day, or it can be years together. It can be years together, 20 years, 30 years, 40 years. Right? So hence there is no limit on the energy perspective. There is no time limit on energy exchange. So it can be a day or it can be years together. Right? So remember, size is not fixed and the time of exchange of energy is also not fixed. So because of these two characteristics, where the size is not fixed and the exchange of energy is also not fixed, these ecosystems are referred as flexible units. These ecosystems are referred as flexible. Right? So remember, at this stage we say ecosystem is a functional unit which is taken for consideration of the study of exchange of matter and energy, which is ecology. And this ecosystem is open ecosystem, and this ecosystem is flexible in its nature. Why flexible? Because its size is not fixed and the exchange of energy, the time of exchange of energy is also not fixed. So hence we say it is flexible entity. So remember the three words: functional unit, open system, flexible. Right? Now, next we move on to understand types of ecosystem. Types of ecosystem. Right? Now the types of ecosystems are: these ecosystems can be man-made, like agricultural farm, or any pond which is constructed by the man. So they can be man-made or they can be natural. Natural. But the way in which we classify the types of ecosystem, this is one classification: man-made and natural. But the most elaborate way of classifying the types of ecosystem, when we classify them on the basis of two categories, that is terrestrial ecosystem, that is on the land, and second one is aquatic ecosystem. Water. Terrestrial means land area, like forests, deserts, etc. Forest, deserts, grasslands, etc. So we refer them as the terrestrial part, right? Yes, Suez Canal can also be referred as the man-made one. Many are there. Then aquatic. So the moment when we talk about aquatic, so in the context of ecosystem, there are again two subdivisions of ecosystems in aquatic. So we come across one type of the aquatic where, take an example of river, where the water is continuously flowing, right? Take an example of river where the water is continuously flowing. So we refer that as flowing water. All such ecosystems like river, streams, where the water is continuously flowing, we refer them as lotic ecosystems. So river is an example of lotic ecosystem. Flowing waters, streams, etc. Now, again, second type of is where the water is stagnant, where the water is stagnant. Stagnant. Take ponds, lakes, etc. So we refer them as lentic ecosystem. Lentic ecosystem. So remember, it can be lotic or it can be lentic ecosystem. Lotic means flowing, flowing. Lentic means stagnant one. Apart from that, we also classify these aquatic ecosystems into freshwater ecosystems, or we can define them as the marine ecosystem, that is saline waters. Marine ecosystems. Saline waters are there. This is where we define them, terrestrial and aquatic. Now, certain areas are there where we find river is meeting an ocean or a sea. Now, river is fresh water and ocean water is saline. Now, the region where we find the river water meets to the ocean. So this is an area. This is an area where the fresh water mixes with the saline water, and the nature of that water is not very saline and not very fresh. We refer such types of waters generally as brackish waters. Brackish waters. We see them in estuaries, deltas, etc. Brackish water, not saline as ocean and not fresh as that of the rivers. So you can add the third one called as brackish water ecosystems. Estuarines. Estuaries. Is it clear? So estuaries and delta. In the context of geography, you have studied that. In the eastern side of India, we find deltas, but in the western side or west coast of India, we find estuaries. Narmada create estuary, Tapi create estuaries, but Kaveri, Krishna, Godavari creates deltas. So deltas are there in the eastern side and estuaries are there in the western side. And deltas and estuaries, we always find the nature of water is brackish type of water. Brackish means it is not as much as saline as the ocean or sea and not fresh as that of the river. So such waters we refer them as brackish waters. They're generally referred as productive ecosystems. So these brackish water ecosystems, they are most productive. We'll see that later. What is this productive aspects are there, right? So we can define all the ecosystems into man-made and natural. Within the natural, we can define them as terrestrial and aquatic ecosystems. And within aquatic, lentic ecosystem and lotic ecosystem. That is flowing water and stagnant water. And then based on the nature of the water, fresh water, saline water, that is marine. Marine means oceans. And then we talk about estuaries, brackish water ecosystems. So these are referred as the types of ecosystems. Is it clear? So we made an effort in understanding the ecosystem, certain aspects of that, then types of ecosystems, right? See, estuaries and deltas you have already studied. Deltas are the areas where large amount of sedimentation is done, whereas estuaries is area where we don't find much sedimentation, where we don't find much sedimentation, where the river reaches to the ocean water. In the context of India, we find deltas here: Kaveri Delta, Krishna Delta, Godavari Delta, because of shallow waters and many reasons for that. Shallow waters of the oceans and the river run for long distances and they make sedimentation. So heavy sedimentations are there, heavy deposits are there, and these deposits creates the deltas in the eastern side. So we find deltas in the east coast of India, but we don't find the deltas in the west coast. No deltas in the west coast. In fact, the Narmada and Tapi, they always create estuary. They always create the estuaries, right? So estuaries means where the river is reached to the sea or ocean, where it does not have much sediments, or the water is steeper there, the water is deep there, and because of that it is unable to make the sedimentation. And such areas where minimum sedimentation or less sediments are there, we refer that as estuary. Generally the river meets to the sea or ocean here, right? And both are very important in the context of environmental concern, right? Okay, so this is the difference between estuary and delta. So remember, in India we find all the deltas only in the eastern coast, like Krishna, Godavari, Kaveri, Mahanadi, Ganga, Brahmaputra delta. We don't have any deltas in the west coast of India. If you take Sharavati, if you take the river Narmada, Tapi, all west flowing rivers, they always create estuaries but not the deltas. But estuaries and deltas both will have brackish water, and deltas and estuaries are generally referred as most productive type of ecosystem. We'll read them in the later classes. Okay, now components of ecosystem. See, when we talk about delta, salinity and all, see, salinity and all are again your geographical part. Now, when we talk about the difference in the salinity of Bay of Bengal and Arabian Sea, it is linked with many concepts. Why the salinity of Arabian Sea, why the salinity of Bay of Bengal is different based on mixing of water, based on the temperature perspective, based on the winds, based on something called as thermohaline circulation, what you have read in your geography. Thermohaline. Thermo means temperature, haline means salinity. So based on that thermohaline circulation, we always find that certain areas the mixing takes place very stronger, certain areas the mixing is very less. So that is your pure geography part, right? And as the deltas push, as the more rivers push water in the coastal areas, so obviously that areas will have more amount of fresh waters, right? Okay, now the components of ecosystem. Now whenever when we talk about components of ecosystem, the components of ecosystem means what it consists of. We can classify all the components of ecosystem into two categories, that is called as abiotic components and biotic components, right? Yes, Kishan, it is about something weakening of amok. Amok means Atlantic meridional overturning current. So generally when we talk about this, all these are important in the context of your studies in geography. Amok, Atlantic meridional overturning circulation. It starts from the Atlantic Ocean, that is the Gulf Stream, and there the surface water moves to the polar region and then it sinks down, then again it comes back. So this is overturning current. Generally we refer that as the movement of ocean water from one ocean to another ocean. So this is called as global conveyor belt. So AMAC is a part of the global conveyor belt, and they are very much affected by the temperature as well as salinity. Now, due to melting of the glacier, I'm telling, due to melting of the glacier, large amount of fresh water is adding to the areas. And this fresh water, when it is added to the ocean, that part, the salinity decreases. And that will have an impact on ocean circulation. And the classical example is AMOC, Atlantic Meridional Overturning Current. Very well identified, right? So you have to make the linkage of that in the context of your geography. Sometimes they may ask AMOC and its impact on environmental concern or impact of climate change on AMOC. So when I take climatology, sorry, when I take the climate change, there you can put, we can make more discussion on that. Is it clear? Okay. Now moving back to components of ecosystem. Now the components of ecosystem, we can define them as abiotic components and biotic components. That is living components and non-living components. Living components and non-living components. Non-living components. Now both are very important in the context of ecosystem. Now the abiotic components, they are referred as rain, light, wind, temperature, etc. Abiotic components. And all the factors which are associated with the soils, all the factors which are associated with the soil. Its pH values, its topography, its composition. We refer that as edaphic factors. So edaphic factors means soils, because soil is a very important abiotic component of the ecosystem. So it is study of soil, its pH value, its mineral composition, etc. We refer them as the soil and its study, edaphic factors. The moment when you say edaphic factors, it is talking about soil, right? Then living components, they are autotrophs, heterotrophs, and saprotrophs. Generally, we refer them as producers, consumers, and decomposers. And within the consumers, we have four major: primary, secondary, tertiary, right? So we have many types to be defined there. We'll take up them with the definitions. First, we'll try to understand abiotic components of ecosystem. Abiotic factors. Now, abiotic factors like light, rain, temperature, soil, etc. are very significant in defining the flora and fauna. So these abiotic factors influences the growth of flora. That is, which type of the plants grow in particular climatic conditions. If you take the polar regions, we find the temperature is very less. Sunlight is also not reaching there. So hence we don't find big trees. So we can find the lichens, mosses, very sensitive vegetation in that areas. Why? Because sunlight is not there. Temperature is also not high. If you take the area near equator, where the continuous rainfall is there, we always find evergreen forests are there. Continuously we find evergreen forests are there. Now certain areas where rainfall variations are there, we find certain trees shed their leaves. Hence, abiotic factors determines the type of vegetation. Abiotic factors determines the type of vegetation, determines which type of flora are there. And this abiotic factors also determines what type of animals are found there. Also determines the animals, that is fauna, right? So in the polar regions, the animals are not the same what you find in the equator. At the tropical areas, we don't find the same animals which you can find. In the grasslands, the animals are different because they have adapted to particular environmental conditions. So hence, abiotic factors like temperature, rainfall, soils, moisture, all these influences the distribution of flora and fauna. So that's why, because of these variations, a desert is having different flora and fauna. Tropical area is having different types of characteristics. Polar regions are having different characteristics. At 30-degree latitudes, different characteristics. So hence, the variation in the abiotic factors are influencing the distribution of flora and fauna. So please remember, they play an important role in distribution of flora and fauna, because these plants and animals have adapted to particular environmental conditions. So what is environment? The physical space surrounding them. And this environment consists of temperature, consists of the winds, consists of rainfall, the physical space, etc. Right? So abiotic factors defines the flora and fauna. Now certain abiotic factors here, like light. Now light is very important for the plants for process called as photosynthesis. Right? And there are certain plants which survive very well when the sunlight is there, and we refer them as the heliophytes. Which needs more sunlight. They always produces more. Their productivity is high only when there is sunlight is there, where the light is seen. Example, many green plants, including sunflower. Now, there are certain plants which are referred as shade-loving plants. Which we see in the gardens, where they can survive even in the low lights, where they can survive even in low intensity of light. And we refer them as sciophytes. Right. So based on the light, we can define them as heliophytes. Helio means sun. Sun. Heliosphere, sun. Heliophytes. And sciophytes, shade-loving plants. Heliophytes are the one which requires more light, and sciophytes, shade-loving plants. And this light is also very important for animals, for their activities, maybe for respiration, maybe for movements, maybe for reproduction. So light is also very important even in the context of animals, maybe for productions, reproductions, etc. So this is one factor. Now, apart from that, we talk about other factors. And before that, you should understand that Earth is tilted. It is tilted at an angle of 23.5 degrees. It is tilted. And along with the tiltation, it is revolving around the sun. Earth is tilted and it is revolving around the sun. So because of this tiltation and revolution, we find that the sun makes apparent shifting to the north and south. Because of that, we find the apparent shifting of the sun is there. Apparent shift of sun. So that means that the vertical radiations of the sun, sometimes they fall exactly on the equator. We refer that as equinoxes. And on June 21, we find the vertical radiations of sun fall exactly on Tropic of Cancer. We refer that as summer solstice. And on December 22 or 21, we find the sun radiations fall exactly on the Tropic of Capricorn. We refer that as winter solstice. So this apparent shifting of the sun creates 4 special days in a year. That is 2 equinoxes and 2 solstices, equal days and nights. Then long days, long winters. We refer them as equinoxes and solstices. And hence we say that because of the tiltation and revolution, we find the temperature which is experienced by a region during the summer season is higher, and the same region will experience the cold temperature when the sun apparently shifts to the Tropic of Capricorn. I am repeat, during the month of June, the Tropic of Cancer will be experiencing high temperature. But the same geographical area during the month of December will experience less temperature or cold temperature. Why? Because the sun has apparently shifted to the Tropic of Capricorn. So we refer that as apparent shifting of the sun, or we say shifting of subsolar points. We say shifting of subsolar point. Subsolar point. Now, because of shifting of subsolar point, we always find there is a variation in the temperature. Variation in the temperature, because wherever sun is there, the temperature will be more in that areas. So there will be variation in the temperature. Temperature varies. Now, in the context of geography, you already studied that temperature is inversely proportional to pressure. More the temperature, less will be the pressure. Less the temperature, more will be the pressure. Right. So this variation of insolation creates a temperature gradient, what you are read in geography. And this temperature gradient in turn creates a pressure gradient, which creates pressure gradient. And this pressure gradient is responsible for the creation of the winds, the horizontal movement of the winds. And these directions are governed by the change in the temperature in that regions. Sometimes we find onshore winds are moving there, and the same area will experience offshore winds. I'm repeating. Due to the change in the temperature, the land may experience onshore winds at one season, and the same land may experience offshore winds in another season. So it means the directions of the winds are governed by the change in the pressure. And this change in the pressure is in turn is associated with the apparent shifting of the sun. So hence we find the pressure also varies. Pressure varies. And this pressure is responsible for making variations in the winds like onshore and offshore, and in turn they affect rainfall pattern, because onshore winds will bring heavy rainfall and offshore winds which move from land to the ocean are dry winds. So this in turn will create impact on precipitation or water availability. Is that clear? See, the pressure and temperatures are inversely proportional in the context of your climatology. You might have read that in your gas laws. So in the gas laws, pressure and temperatures are directly related where the volume is not constant. Where the volume is constant. In gas laws, the temperature and pressures are directly related when the volume is kept constant. But in climatology, the volume is not constant. I'm repeating. In climatology, the volume is not constant. So with increasing temperature, the pressure decreases. It is just like you are having a cooker. So in that pressure cooker, if you kept or keep some water, and if you start heating that, if you cover the cooker with a lid, then by default the volume is constant, where with the temperature pressure increases, where the volume is constant. But if you remove the lid of the cooker, if you remove the cover of the cooker, when you heat that, then at that case the volume is not constant. And when the volume is not constant, then whatever the vapor which is produced there will expand outside. So hence, with increasing temperature, the pressure decreases in the atmosphere or in climatology. Why? Because the volume is not constant here. Is it clear? Okay. So the same thing are seen here. So due to apparent shifting of the sun, the temperature also varies, and the rainfall or the availability of water also varies from Tropic of Cancer to the Tropic of Capricorn and the equator. So it influences the wind directions and it influences the temperature. Is it clear? Right. Okay. So now next we move on to understand the influence of these with reference to that. See, when you talk about the crust, core, and mantle, we are talking about the characteristics of the Earth's interior. I'm talking about climatology, which is open path. Right. Okay. Now, based on the temperature, we find the temperature varies from equator to the north and to the south due to insolation and revolution. So hence, based on the temperature, where near the equator, if you see this area near the equator, we always find high temperature persist throughout the year. And those vegetations which are found near the equator, where high temperatures are there, evergreen forests are there, we refer them as megatherms, which are near the equator, where we find high temperature throughout the year. Then when we move on to the tropics, that is Tropic of Cancer and Tropic of Capricorn, that is subtropical areas near that areas, subtropical, that is 30 degrees, 40 degrees, what we refer them. So in those areas, we find that when the sun is present, they will have high temperature. And when the sun moves to the Tropic of Capricorn, then the Tropic of Cancer will be having low temperature. So alternate high and low temperature is experienced by the same region due to apparent shifting of the sun here. So those areas, we always find alternate high and low temperatures are seen. And we refer them as mesotherms. And in this mesotherms, a typical characteristics of the vegetation is where they shed their leaves, and generally we define such types of vegetation as deciduous, which shed their leaves. So megatherms, mesotherms near the tropics. Then we have microtherms, that is around 40-50 degree latitudes, where the temperature is very less. So in these areas where the temperature is very less, in those areas we find a type of vegetation which we refer them as coniferous type of vegetation. And they are nothing but microtherms, right? Then when you move on to the poles regions, or higher altitudes where the temperature is very, very less, very low temperatures are there, so we refer them as hekistotherms. Like Arctic regions, where we find the vegetations like lichens, mosses, very sensitive type of vegetations, we refer them as hekistotherms. So we can classify the vegetation either megatherms, mesotherms, microtherms, or hekistotherms based on the temperature variations. Is it clear? So at the equator, it is megatherms. Near the tropics, it is mesotherms. At 50 degrees, 60 degrees, we have microtherms, low temperature, coniferous, boreal forests, right? Then hekistotherms, where the temperature is very, very less. We define them as hekistotherms, like lichens, mosses, etc. Very sensitive type of vegetation, right? Then water, that is availability of water, maybe through precipitation or maybe through any type. So we refer that as availability of water. Now certain areas are there. If you take equator, at the equator, we always find heavy rainfall is throughout the year rainfalls are there. So generally we say the convectional type of precipitation is seen in the equator. Heavy rainfall throughout the year is seen at equator. So we don't have any seasons in the equator. All the months it is having heavy rainfall and high temperatures. And those areas will always have evergreen vegetation. Evergreen vegetations, equatorial rainforests, tropical rainforests, evergreen forests, right? Now, due to apparent shifting of the sun north and south, we always find that the same regions will have rainfall during the winter season and low rainfall during the summer season. So I'm talking about something, the area 30 to 40-degree latitudes in the western margins of continents, right? So 30 to 40-degree latitudes in the western margins of continent. Western margins of continent. I'm giving an example of that, where the rainfall is only during the winter season and very less rainfall during the summer season. So there the adaptation has to be done. The normal leaves will not survive. The normal leaves will not survive. So there the trees are stunted. Short trees will be there. Short trees. We refer them as stunted trees. And not only stunted trees, the leaves are fleshy so that they can survive the winter along with rainfall. Fleshy leaves. Fleshy leaves. So short trees, we refer them as shrubs. Shrubs. What you see in the Mediterranean type of climate. Mediterranean type of climatic region, which receives rainfall during the winter season. And such vegetation, we refer them as sclerophyllous. Sclerophyllous. Right. So fleshy leaves, fleshy means thick leaves, where the water will not stay there. It will make the water to move down. Slippery, slippery. Right. Then certain areas where we have heavy rain during the summer season and low rainfall during the winter season. So in those areas, we find the vegetations predominantly are grasslands. Grasslands. And certain areas where the rainfall is very less, like deserts, very low precipitation, like deserts. So there also we find the plants have made to the adaptation, like they are having thorns, fleshy stem, and they have adapted to the scarcity of water. We refer them as xerophytes. Example, cactus. Xerophytes in the desert areas. Right. Now the thorns will protect them from herbivore animals, which can eat up all that leaves and flesh. So because of the thorn, they can't eat them. And the fleshy stems store the water. Right. So these types of adaptation we can see whenever there is a variation of waters are there. So based on that, we can have evergreen forests, we can have sclerophyllous, we can have grasslands, and we can also have such types of vegetations called as the xerophytes. Is it clear? Okay. Now, edaphic factors. Edaphic factors means we are talking about the soils. Now, soil is very important component, right? Now, soil is referred as important natural resource because it provides nutrients to the crops. It provides nutrients to the crops and plants. Second, the soils provides moisture to the plants. Moisture means water to the agricultural crops or plants. And third one is the soil also provides physical support to the plants. physical support to the plants. So hence soil is very, very important in the context of growth of the plants, crops, or in general we say the flora. Is it clear? So they play a very important role. Now this soil, it depends on topography. This soil, it depends on topography. If any areas are having plain topography, like northern plains, where we find thick soils are there, thick soils are there, if it is plain topography, and this thick soil will support growth of more plants, support the growth of vegetation. And if any areas where we are having steep slopes, there we'll have thin soil. So thin soil will not support the growth of large trees. Small vegetation can be seen. And in fact, this thin soil or the steep slopes are always associated with erosion. Thin slopes or steep slopes are always associated with soil erosion. Right? So topography is one important aspect. So wherever plain areas are there, we will find thick vegetations are there, thick soils, thick vegetation, because soil provides them nutrients. And wherever steep slopes are there, then the vegetation will be scarce in that areas. It is associated with erosion. That is one. Water and as well as physical support for the growth of plants. Apart from that, we also find the soil's pH values, negative logarithm of hydrogen, plays an important role in growing the crops or growing the plants or growing the vegetation. So pH values are 0 to 14. 0 to 14. Now, when we make an assessment of that, so 0 to 7 is acidic and 7 to 14 is alkaline or basic. So neutral is 7. Neutral is 7. So we find all the varieties of plants which can survive even in the acidic medium. We have the plants which can survive in the alkaline medium, and we also have the plants which can survive in the neutral medium. So those plants which survive in the acidic mediums, we refer them as oxylophytes. Which survive in the acidic medium, we refer them as oxylophytes. Oxylophytes. And the best example of that is Arctic grass. Oxylophytes, which survive in the acidic medium. And there are many plants which survive in the saline medium. Alkaline means saline medium. We refer them as salt tolerant. And we refer them as halophytes. Example, mangroves. The salt tolerant plants. Is it clear? So low rainfall in the summer and high rain in the winter. It is a Mediterranean climate, 30 to 40 degree latitudes in the western margins of continents. I'll repeat. Low rainfall in the summer and high rainfall in the winter is experienced in the Mediterranean climate, and this you have read in your geography, due to apparent shifting of the pressure belts. I'm talking about that Mediterranean climate, which is 30 to 40 degree latitudes in the western margins. of all continents. We refer that as Mediterranean climate. So these all are your basics aspects of geography. Is it clear? So when we talk about when you talk about the perspectives of the pH values, so we have oxalophytes, we have halophytes, and there are many crops which can be seen in between 7 to 8 medium of pH values. So we can have a break of 15 minutes. So and then we can continue the class exactly at uh, 7:50. The class will resume at 7:50. See, hydrophytes and all that. Flora means plants and fauna means animals. Don't get confused, right? So fauna means animals, flora means plants. Hydrophytes means it is a plants which you are talking. Phytes means plants. Okay, welcome back. Hope I'm audible as well as visible to you all. Right. So one question was there regarding why they receive rainfall only in the winter season. I told that these are the areas that is 30 to 40-degree latitudes in the western margins of the continents, and they receive the rainfall due to shifting of the pressure belts. So generally in all the time, these areas 30 to 40-degree latitudes, they come under the impact of trade winds, and the trade winds moves from east towards the western side, and they are offshore in the western margins at 30 to 40 degrees latitudes. But when the apparent shifting of the sun takes place, so the pressure belts will also shift. If the pressure belt is shifting towards the northern side, that means summer season is there in the northern hemisphere and winter season is there in the southern hemisphere. Now in the southern hemisphere at 30 to 40-degree latitudes, in the place of trade winds, we find westerlies will be hitting to that area. And the direction of westerlies is different from the trade wind. Trade winds move from east to the west. Westerlies move from west towards the eastern side. And these westerlies, when they move, they carry the moisture from the oceans and they hit to the coastal areas, 30 to 40 degrees, and they become onshore. And these westerlies, which are onshore in the west coast or in the western side of the continent, due to their moisture, they provide rainfall. So hence, this 30 to 40-degree latitudes receives rainfall only during winter season, and that is due to change in the wind patterns. You are correct that wind always moves from high pressure to low pressure, but here it is beyond that. The area comes under the impact of westerlies, and the westerlies provides rainfall in the 30 to 40-degree latitudes in the western margins of the continents in the northern hemisphere as well as the southern hemisphere. Right. So remember that, Kishan, ITCZ is intertropical convergence zones, which always shifts north and south. ITCZ always shifts north and south. Along with that, the pressure belts will also shift. Subtropical high pressure belt, polar high pressure belt. So these are 7 pressure belts what we find. Equatorial low pressure belt. So they also shifts. In geography, you have studied that the pressure belts shifts along with the sun. They always follow the sun, and hence they make an impact in the wind patterns. If you see the regions near Tropic of Cancer and Tropic of Capricorn near the equator, trade winds are dominant, and trade winds are moving from east towards the western side, and they are onshore in the eastern side and offshore in the western side. But due to shifting of pressure belt, then the same region where the trade winds were hitting during the winter season, that region will be under the impact of westerlies, and westerlies, they move from ocean to the land and they bring heavy rainfall in the western margins. Okay, I hope it is clear now why that 30 to 40-degree receives rainfall only during winter season, and that is referred as Mediterranean climate. That is the unique thing of the Mediterranean climate, that it receives heavy rainfall during the winter season, and that is mainly due to shifting of the pressure belts. That region comes under the westerlies during the winter season. Clear? Okay, done. Now, next is biotic factors. So, biotic factors means living factors, what we say. So, here the biotic factors consist of producers. All the producers are referred as autotrophs. All the producers are referred as autotrophs. But within the autotrophs, we can subdivide them. All autotrophs are subdivided into two major categories: those which produces their energy in the presence of sun, and those which produces the energy in the absence of sun. So we refer them as photoautotrophs and chemoautotrophs. So remember, autotrophs are subdivided into two categories: photoautotrophs and chemoautotrophs. Photoautotrophs are those which produces the energy in the presence of sun. In the presence of sun. Generally, we refer that as photosynthesis. Photosynthesis. Right. So these green plants, they use the sunlight, and in the presence of sunlight, by taking the atmospheric carbon dioxide, they produce their energy, and also they release oxygen to the atmosphere. They release oxygen to the atmosphere. So during photosynthesis, carbon dioxide is taken and oxygen is released along with the food which is produced, carbohydrates which are stored in the plants. And we refer that as the photoautotrophs. So photoautotrophs are those plants which produces their energy or the food in the presence of sunlight. Now, not all the sunlight is important, or not all the sunlight is used for developing the photosynthesis. This photosynthesis is carried, or it is maximum in the wavelength of the light. It is ideal when the wavelength of the light is somewhere around 400 to 700 nanometers. Not all the wavelength of light is what influencing the sunlight, but the sunlight of wavelength in between 400 to 700 nanometers is something which is ideal for photosynthesis. And this wavelength 400 to 700 nanometers is referred as photosynthetic active radiation. Photosynthetic active radiation. Generally, we refer that as PAR. Right? PAR. Right? Photosynthetic active radiation. So within that wavelength of 400 to 700 nanometers, the plants produces oxygen, produces their food. And we refer this process as photosynthesis. I'll repeat. Photoautotrophs are subgroups of autotrophs which produces their food by themselves, produces their food or energy by themselves in the presence of sunlight. We refer them as photoautotrophs. And among all the sunlight wavelength, the wavelength between 400 to 700 nanometers is referred as photosynthetic active radiation. And this photosynthetic active radiation is ideal for maximum photosynthesis or maximum food productivity in the plants. Is it clear? And always remember, as the sun always shifts north and south, so this photosynthetic active radiation also varies from time to time and varies from altitude. So this also varies with altitude, varies with latitude, and varies with time also. Altitude means height wise. Latitude means from equator to the poles. And time means summer season, winter season, morning season, afternoon season. So in the afternoon season, we find it is more. In the summer season, photosynthetic active radiation is more because of high presence of sunlight. And we refer them as photoautotrophs. Is it clear? Now, second categories are referred as chemoautotrophs. So chemoautotrophs are also autotrophs, but they produces their food in the absence of sunlight. Chemoautotrophs, they produces their energy or food in the absence of sunlight. We refer them as chemoautotrophs, and generally they produce by chemical reaction. By chemical reaction. And we refer them as chemoautotrophs, which produces their food or energy in the absence of sunlight. We refer them as chemoautotrophs. So remember, autotrophs are those species. Autotrophs are those species which we refer them as producers, which produces their food by themselves, either in the presence of sun. We refer them as photoautotrophs. And those autotrophs which produces in the absence of sunlight, we refer them as chemoautotrophs, and they produce by chemical reactions. And generally, these are found in the volcanic vents where the sunlight do not penetrate. Example, we can find them in volcanic vents. If this is volcano, so here in the volcanic vents or in the deep oceans, we refer them as hydrothermal vents. Soils, etc. Soils, etc. Deep soils, I'm talking. Now, the examples of that, we come across Nitrobacter and Nitrosomonas. So these bacteria, which are found in the soils, they are referred as chemoautotrophs. Now, Nitrosomonas, when we say, it converts ammonia into nitrites. Which is the energy which is produced there, converts ammonia into nitrites, Nitrosomonas. And when you talk about Nitrobacter, it converts nitrates into nitrites. Nitrites into nitrates. So understand the difference. Nitrosomonas converts ammonia into nitrites, nitrites. And Nitrobacter converts nitrites into nitrates, which plays important role in agricultural activity. So we refer them as chemoautotrophs. Photoautotrophs, chemoautotrophs, right? Now, next is consumers. Now, the moment when we say consumers, they are referred as heterotrophs. So they don't produce their own food. Do not produce their own food. Right? Photoautotrophs, chemoautotrophs. Autotrophs produce their own food. Consumers, they depend. They don't produce, they depend. And here we come across the major subcategories: herbivorous, plant eating animals. Example, cow. Herbivore, plant eating, cow, goat, etc. Then we are having carnivorous, flesh eating animals. Example, lion, flesh eating animals. Then we are having omnivorous, which eat both plants as well as flesh. We refer that as omnivorous. Example, we can give the cats, vegetarian, the cats, right? Omnivorous, right? So we have herbivorous, carnivorous, omnivorous. Then apart from this, we also have certain types of animal species. Yes, you can give dogs also as a omnivorous. We have certain species like crabs, right, etc. So these crabs, they eat the flesh of dead animals. These crabs, etc., they feed on flesh of dead plants, dead animals, sorry. Right. And we refer them as detrivores. We refer them as detrivorous. Detrivorous, which always feed on the flesh of the dead plants and animals. Detrivorous. And generally we refer detrivorous as the subset of decomposers. They are subset of decomposers. Like crabs, vultures, etc. We refer them as detrivorous. So detrivorous depend. They feed on dead plants and animals. They feed on dead plants and animals for their survival. So remember, herbivore, carnivore, omnivore, and detrivorous. Yes, scavengers, they are the same. They are the same. Detrivorous or scavengers, they are the same. Detrivorous are subsets of the decomposers. Now the last category is referred as the decomposers. Decomposers. Now the decomposers can be microscopic, or they can be larger like mushrooms. Microscopic or larger like mushrooms. Now what is the role of decomposers? They play a very important role in the ecosystem. Decomposers, they play an important role. Take this bacteria. Now when any plant or animal dies, any plant or animal dies, we refer that as organic stuff. Dead plant and animal, we refer that as organic stuff. Now these bacteria, they act on this organic part. These bacteria, they act on this organic part, dead plant and animal, and they convert this organic into inorganic substances. They convert this organic into inorganic substances like nitrogen, phosphorus, carbon, etc. Like nitrogen, carbon, phosphorus, etc. So it converts the organic into inorganic substance, dead organic substance into inorganic substance. And the significance of this is these inorganic substance, they enter into the ecosystem. So these inorganic substance, they enter the ecosystem. Enter the ecosystem. It means they are recycled in the ecosystem. They are recycled in the ecosystem. So remember, the organic part is not recycled. When these die, the bacteria decompose them and convert them into inorganic substances. Generally, in the soil formation, you have read something called as degradation. Then we have something called as humification. And after humification, mineralization is when they convert the dead organic stuff, the humus, into minerals like phosphorus, nitrogen, etc. We refer that as humification to mineralization, and that is where the bacteria plays an important role. And these minerals like nitrogen, phosphorus, carbon, which are converted by the bacteria, they enter into the ecosystem, where we say recycling of the nutrients. So it is the role of bacteria which makes the recycling of the nutrients. Recycling of the nutrients. Recycling of nutrients. Now, if you remove the bacteria, then the recycling will not be there. So hence bacteria plays an important role in the ecosystem, where they convert the organic part into inorganic substances which are recycled in the ecosystem. So that's why we come across many types of cycles in the ecosystem called as biogeochemical cycles. Biogeochemical cycles. Biogeochemical cycle. Example, carbon cycle, right? Nitrogen cycle, phosphorus cycle, etc. Right? Phosphorus, etc. So we refer that as biogeochemical. right? So here, understand this part, bio, geochemical. So here, the organic part, which is converted into inorganic component, is the work of bacteria, which we refer them as decomposition. And the bacteria and many organisms like mushroom plays an important role in that, and we refer them as decomposers. Is it clear? So this is what the four categories are there: producers, consumers, right? And in the consumers, we refer them as primary consumers, secondary consumers, tertiary consumers, etc. Right? So these are something which you should remember. So generally, when we say these cycles, fungi, yes, you can put them. So when we say sulfur cycle, phosphorus cycle, carbon cycle, they are where we say the plants, they absorb the nutrients, and when they die, they release back. They enter into the lithosphere, again they come back into the plants in the form of nutrients there. This is cycling of the nutrients is seen from the rocks to the earth's lithosphere, and from there entering into the plants, then again entering into the earth's atmosphere. So generally this biogeochemical cycle talks about the movement from lithosphere, hydrosphere, atmosphere. It keeps on cycling there, right? Okay. Then function, I'm giving you just rough idea about that, right? So that phagocytes and all, you can read them in your class 11th, where they talk about the classification of animals. They are examples which you can put them, right? Now, functions of ecosystem, balancing will take up later. Humification, mineralization, catabolism. See, when we talk about this humification, all, they are all your geography stuff. When you talk about the geography stuff, we come across something called as soil formation. In geography, you have studied something called as soil formation, right? And this is referred as pedogenesis, right? That is the soil formation process which is involved. Study of soil is called as pedology. Now, in the soil formation, we find many factors are there. It can be parent rock, it can be temperature, it can be the evaporation, right? So many factors are there. Among the factors, we talk about living organisms and dead organisms, which plays an important role in the soil formation. Now, when the plant and animals die, they are referred as organic stuff. This is organic stuffs. And this organic stuff is reduced into smaller sizes. And we refer that as biodegradation. Biodegradation. When it is reduced into smaller stuffs. That is the first stage, biodegradation. And after the biodegradation, it is converted into humus, organic matter. We refer that as humification. So this is the first stage. This is the second stage called as humification, which is converted into minute organic part. So humus, what we say in soil formation, we have something called as humus or organic part. And on this, the bacteria keep on acting on that, and they convert this into inorganic substance. So remember, humus or is organic part, and here we find the bacteria act on that. The bacteria consistently act on that, and they convert the organic stuff into inorganic substance. They convert this organic stuff into inorganic substance, and this inorganic substance like convert that into carbon, nitrogen, etc. We refer that as mineralization. Right? like the gases, what we say, mineralization. And these mineralizations, that is when the organic stuff is converted into inorganic substance, then they enter into the rocks or the earth's lithosphere, and from there they again enter into the ecosystem. So this is called as the biodegradation, humification, and mineralization. And here the bacteria plays an important role in converting the organic stuff into inorganic substance. And these inorganic substance are something which are recycled. Which are recycled. Right. Okay. Right. Now we move on to understand the functions of ecosystem. I hope it is clear now. Right. Okay. Biodegradation means breaking the organic stuff into smaller. Degradation means breaking. In geography, you have read something called as degradation of rocks, breaking up of rocks. So here, when the organic stuff is broken by the bacteria or the living organisms, we refer that as biodegradation. Living organism reducing that organic stuff into smaller, we refer that as biodegradation. Okay. Now, functions of ecosystems. Now, the first one is referred as matter. Right. So, while defining the functions of ecosystem, you should remember that in the ecosystem there is always exchange of matter and energy is done. There is always exchange of matter and energy is there. Right. So matter and energy, and this systematic study is a part of ecology. Now first we'll try to understand how this matter is exchanged, then we move on to energy part. So matter is nothing but nutrients, right? Nutrients. Now how this matter or the nutrients are exchanged in the ecosystem with its surrounding environment. Now if this is a tree or grasses are there, tree or grass are there, right? Now this tree or grasses are eaten by say rabbit, right? And whenever when you talk about this plants, these plants they absorb the nutrients like nitrogen, phosphorus, etc. from the earth's part, that is lithosphere, from the rocks, from the water, etc. They absorb the nutrients. Generally we refer them as macronutrients and micronutrients, which are responsible for the growth of the plants. So this is how the nutrients enters through the roots, and these nutrients are used by the plants to produce their energies, and these nutrients are seen in the plants. Now when the rabbit eats that, then the nutrients are transferred to the rabbit, because rabbit is a consumer. Plants produces energy by photosynthesis, primary producer. These produces the energy and it is consumed by rabbits. So the nutrients are transferred to the rabbit. Focus only on the nutrients. I'm talking only about the matter. The rabbit consumes that. Now after that, this rabbit is eaten by say dog. It is eaten by the dog. Now the matter which has transferred from the plants will reach to the rabbit. Rabbit will use it for its own activities, and then rabbit is eaten by the dog. Then the matters or the nutrients are transferred from the rabbit to the dog. Now when the dog and rabbit die, both when they die, rabbit and dog when they die, even if the tree when it dies, then it is converted into organic part. That is, dead plants and animals are organic part. And these organic part, they are acted upon by bacteria. So on this, the bacteria will act. And what is the role of bacteria? They convert the organic stuff into inorganic substance. They convert this organic into inorganic. stuffs like nitrogen, phosphorus, calcium, etc. Convert that into inorganic stuffs. And these inorganic stuffs, they enter into the earth crust, soils, rocks, etc. They enter into the earth's crust, inorganic like nitrogen, phosphorus. And from the earth's crust, they enter into the plants through the roots. Into the roots. So when they enter into the plants, again they become used by the plants, which convert into organic stuff. And then again, bacteria reconvert them into inorganic substances. So this flow of the nutrients is cyclic in the context of ecosystems. And generally, we have different cycles which are mentioned there. We refer them as biogeochemical cycle, phosphorus cycle, potassium cycle. That's what the sedimentary cycle, what we say, right? So they are in the form of different cycles. We refer them as biogeochemical cycles. Biogeochemical cycles. So hence, the bottom line here is the matters or the nutrients in the ecosystem. In the ecosystems, they always follow the cyclic path. They always follow the cyclic path, right? So the matters or the nutrients, they are always in the cyclic. They move from one to another in different pattern. See, soil formation, when you talk about that, please understand that soil formation is your geography part. So in that, the formation of soil itself is a long process. It takes millions of years. When the rock breaks, we refer that as regoliths. And regoliths, they undergo physical and chemical change, and they convert themselves into smaller particles called as soils. There are many factors which makes the soil formation. Among many factors, one factor is living organisms and dead organisms. So dead organisms, they always contribute organic stuff to the soil, which we refer them as humus. When the plant or animal dies, we refer that as the organic stuff. And on this, the bacteria act. And these bacteria converts this organic stuff in three processes. The first process is called as reducing that into smaller parts. We refer that as biodegradation. Then continuously act on that, and they convert that into a small humus. And then again, they act continuously on that, where we refer them as humification. And after that, these bacteria convert this humus into inorganic stuff called as mineralization, like nitrogen, potash, etc. And these are something which circulated or which are recycled in the ecosystem. So hence, bacteria plays an important role in converting the organic into inorganic substances. And this is what we refer that as matter or nutrients. So hence we say this matter or the nutrients, they always follow the cyclic path in the ecosystem. So hence, in the ecosystems, the nutrients are always in the cyclic pattern. It is something like this. Green plants or grasses, when they are eaten by the rabbit, then the nutrients are transferred from green plants to the rabbits. When it eats that is the food what it eats. So the nutrients are transferred to that. When the rabbit is eaten by the dog, now whatever amount of nutrients which are transferred by the plants have reached to the rabbit, and from the rabbit they have reached to the dog. When the dog dies or when the rabbit dies, then it is organic stuff, dead organic part. And this is where the biodegradation takes place, humification takes place, mineralization takes place, and they convert them into inorganic substances by the role of bacteria. And then these inorganic substances like nitrogen, phosphorus, potash, calcium, they enter into the earth's crust due to the work of bacteria. And then again, they enter into the green plants through macronutrients and micronutrients in the form of them through the roots. And we refer that as cyclic pattern. So hence, We always say that the matter follows the cyclic path in the ecosystem. That is the first part, right? Okay. Now the second perspective is energy flow. The first one is matter. So matter is always cyclic. Matter is always cyclic. You should remember that point. Now the second one is energy flow. Now the moment when you talk about energy flow, understand that energy is produced by a process called as photosynthesis. I'm talking about photoautotrophs. Photoautotrophs. Energy is produced by a process called as photosynthesis. Right. And this energy is very important for metabolic activities. Their growth, reproduction, etc. Right. So remember that energy is produced by a process called as photosynthesis, and this energy is important for metabolic activities, growth, reproduction in the ecosystem for different organisms. Right. Now this flow of energy this flow of energy is always referred as sequential. Sequential. And it is unidirectional. It means it never comes back. It is sequential. Sequential, unidirectional, unidirection, and non-cyclic. Non-cyclic. It's not that matter, not like the matter which is recycled. Right. Now understand here. The moment when the energy is produced by a process called as photosynthesis, the plants which are produced the energy, they will consume for them survival. They will consume the energy for their survival. Right. And when these plants are eaten by, say, primary consumer, when they are eaten by primary consumer, like rabbit, so rabbit will also use a part of energy for its reproduction, growth, etc. So the rabbit will also use energy for its reproduction, metabolic activities, etc., its growth, etc. So every organisms in their hierarchy, primary consumer, secondary consumer, tertiary consumers, they will always utilize the energy for their growth, respiration, and metabolic activities. And this energy which they have used, generally in the study of ecosystem, we say it is energy lost. Energy lost means the energy which is consumed. The energy which is consumed by these organisms, we refer that as energy lost. Why? Because we are making an effort to understand how the energy is transferred from primary consumer to secondary consumer to the tertiary consumers. So the amount of energy which they have utilized for their survival, their reproduction, is generally referred as the energy lost in the flow. Lost means the energy is consumed by the primary consumers like rabbit. Right. So this energy loss means it is the energy which is consumed. Energy loss means energy which is consumed. And this energy which is produced in the green plants, we refer that as primary producer. Then it enters into the primary consumers like rabbit when it eats that. And rabbit will also use the energy for its survival, for its reproduction. And this energy which is used by the rabbit for its survival production, we refer that as energy loss. Energy loss. An amount of energy which is used by rabbit. So we refer that as energy lost. And after that, the remaining energy is transferred to the secondary consumer when the rabbit is eaten by, say, dog. When the dog eats that, then the remaining energy is transferred to the dog. Now the dog will use the energy for its reproduction, metabolic activities, growth, etc. It has used the amount of energy for itself, and that is referred as the energy lost by the flow, which is consumed by the dog. Now when the dog dies, it is eaten by, say, tiger or lion. So the remaining part of the energy of the dog is carried to the lion or tiger there. So this is what we refer that as flow of energy. Right? So understand this. This flow of energy is explained by two laws of thermodynamics. One is energy can neither be created nor be destroyed. The second one is there is always loss of energy during the transformation. There is always the loss of energy during transformation. And energy can neither be created nor be destroyed. It can be transferred or it is transmitted from one to next one. Transferred and transformed from green plants to rabbit, dog, tiger. It is transferred in one form to another form. Is it clear? So when that animal dies, the energy is released to the systems. Understand this. Understand this. If this is a green plant, we have a green plant here. Or grasses, which are referred as producers. Green plants are producers, which produces the energy by using photosynthesis, which produces the energy by process called as photosynthesis. Photosynthesis. So it is the total energy which is produced by the green plants, by that ecosystem. So we refer this as total energy. Which is produced by the green plants or grasses. Now this green plants or the grasses, it is eaten. It is eaten by, say, rabbit. Rabbit. Now, before transferring the energy to the rabbit, a part of energy is used by the green plants for their growth. Part of energy is used for their metabolic activities. Part of energy is used by that. And this energy which is used by the green plants for their metabolic, respiration, transpiration, etc., for their growth, we refer that as energy lost. Energy lost. And the remaining energy is transferred to the rabbit when the rabbit eats the green plants. Now this rabbit will also use the energy for its reproduction, for its growth, etc. And this energy which is used by the rabbit for its growth, reproduction, generally we refer that as energy lost. Energy lost. And this rabbit is eaten by, say, dog. Now when the dog eats this rabbit, then part of energy, the remaining energy, is transferred to the dog here. And the dog will also use the energy for its reproduction, for its growth. And this is also called as energy lost in the ecosystem. And when the dog is eaten, when the dog is eaten by, say, tiger, eaten by the tiger, then the part of energy is transferred to the tiger. It transferred to the tiger. So this flow of energy is sequential. This flow of energy is sequential, where we find one organism, the rabbit, is eating the grasses, or in turn, rabbit is eaten up by the dog. I'm repeating, dog eats the rabbit, or in turn, it is eaten up by tiger. And this process of being eaten and eating up of, where the energy is flowing in the ecosystem, we refer this as food chain. A simple definition of food chain is flow of energy, or the sequence of eating or being eaten up, is referred as food chain. Right? Energy which is transferred from green plants to the primary consumer, to the secondary consumer, and to the tertiary consumers, we refer that as food chain. So food chain means the sequence of eating or being eaten up. So here the energy is transferred from primary consumer to the secondary consumer to the tertiary consumers. So food chain talks about transfer of energy. Transfer of energy. And always remember, it is only in one direction. It moves from primary producer to secondary and then to the tertiary. It will never come back. There is no possibility that the the rabbit can eat the dog. There is no possibility that the dog will eat the tiger. So it is unidirectional. So it is always unidirectional. And it is in sequence, primary consumer to secondary consumer to the tertiary consumer. It is in sequence. So it is unidirectional plus sequence. Right? Now, each stage is represented by separate tropics. Primary consumers have separate tropics. Secondary consumers have separate tropics. Tertiary consumers have separate tropics. So it is a name which is given to the category of the species there. So generally the rectangular box which represent them, we refer them as tropics. So it is tropics of primary producer, tropics of secondary consumer, tropics of tertiary consumers, right? And this flow of energy provides structural stability to ecosystem. That is, reproduction means the number of species will increase, their strength increases, the species number will increase. So they provide structural stability, that is reproduction. Their numbers increases, numbers of the species increases. So it provides structural stability, strength, population in the ecosystem, right? And these tropics, they give an idea that whether the particular tropic, whether it is herbivore, omnivore, or carnivore, it gives that whether it is herbivore, that is rabbit, whether it is herbivore, or whether it is omnivore or carnivore. So hence we say that these tropical structures, they provide their organization and pattern of feeding. That is, whether they are primary consumers, whether they are secondary consumers, or whether they are tertiary consumers. tertiary consumers. Is it clear? And in all the tropics, the energy is stored. In all the tropics, there will be an energy. There will be an energy which is stored there. Right. So these tropics will always store the energy. Primary consumers will have their own energy. Secondary consumers will have their own energy. Tertiary consumers will have their own energy. So they will have their own energy which are stored. Right. Now, food chain explains the first law of thermodynamics. That is, energy is transferred from one level to another level. The energy is transferred from one level to another level. That is primary to secondary to tertiary. Right. Tropics means they are referred as the group of primary consumers. All rabbits, herbivores, we refer them as primary consumers. If you take carnivores, carnivores are referred as, say, secondary consumers. Right. So tropics means we are talking about the particular species and their feeding habits. Primary consumers, secondary consumers, herbivores, omnivores, carnivores, etc. So when you group all these species in one category, we refer them as tropics. All the herbivores makes one tropic. All the omnivores, they make one tropic here in the study. So hence we refer them as tropics. Primary consumers, one tropic. Secondary consumers, tropic. So instead of naming them as a group, we use the term called as tropics. So these organisms are seen in the tropics. So first tropic, tropic level, primary consumer. Secondary tropic, second level. Tertiary consumer, third tropic level. And these energies which are stored in them, we refer them as the tropic structure, which provides their feeding habits and their organization structure there. Okay, so this is one part. Now, I explained that how the energy is transferred. Now, the second aspect of the theory is that which talks about the loss of energy. Now, we'll try to understand this perspectives. So, the flow of energy is something called as food chain. Now, what is the loss of energy? What is the loss of energy? Now, when we talk about loss of energy, understand certain terms. Now, the green plants which are produced all the energy, the green plants which are produced the energy, the total energy, we refer this as gross primary production. We refer this as gross primary production. Gross primary production. Gross primary production, GPP. Now, the energy which is lost at every series or every structure, the energy lost is represented as R. So, R is the energy lost. R is the energy lost. So, remember, energy lost means the energy which is consumed by the primary consumer or secondary consumer. Now, after that, out of this gross primary production, R is the energy which is lost. Now, the remaining energy is transferred. The remaining energy is transferred. Energy is transferred. And this energy which is transferred is referred as net primary production. The energy which is transferred, we refer that as net primary production. So please understand that. The total energy which is produced is referred as gross primary production. The energy which is lost, the species which consume by themselves, we refer that as energy lost. So every stage there will be energy lost. Every stage there will be energy loss is there. And then the remaining energy is transferred from one level to another level. So remaining energy is transferred from one level to another level. That is from primary consumer to secondary consumer to the tertiary consumer. One level to another level. Right. Now we have to understand what is this energy which is lost here, which is the second law of thermodynamics. Right. Now understand this. The primary producers, like all the green plants, they produce the total energy in the first level. We refer that as gross primary production, GPP. Gross primary production, that is the total energy which is produced. Total energy which is produced. Now, out of the total energy which is produced there, a part of energy is used by green plants for their metabolic activities, for their growth. And that energy which is used by them, we refer that as energy lost, which is referred as R. R, which is referred as energy lost. Right. So remember, GPP is gross primary production and R is energy lost. And the remaining energy is transferred to the next level. The energy which is transferred, the remaining energy which is transferred, energy which is transferred is referred as net primary production, NPP. So we define that as gross primary production minus R is net primary production. And always remember, this net primary production is the energy which is transferred from one tropic to another tropics. It is the amount of energy which is transferred from one tropic to another. One tropic to another. Right. So always remember, NPP is transferred from one to another. Now these primary consumers, which forms the tropic structure of the first level, first tropic structure of primary consumers, herbivores generally. So they use the energy for their reproduction, metabolic activities, and this is what we say energy lost by the primary consumers. It is used by them. And after that, the remaining energy is transferred to the next level, which is referred as net primary production. Net primary. So always remember, net primary production is the energy which is always transferred. Gross primary production is never transferred. It is just like your gross salary, and net salary means deductions. Every stage there will be deductions. Is it clear? Then secondary consumers will also use the energy for their survival, and they will also lose the energy which is R, energy which is lost, that is the energy which is consumed by them. And after that the remaining energy is transferred, which we refer them as net primary production, which is transferred from one tropic to another tropics. Now every tropics will have their own energy. Every tropics, that is tropics of primary, tropics of secondary, and tropics of tertiary. So every tropics will have their own energy. And this energy which is seen in every tropics, this energy which is seen in all that, is referred as amount of living crop. Understand this, is referred as amount of living crop. The words are very important. Or another name given to that is, or it is also referred as amount of living crop or standing crop, or standing crop. Now don't go with the dictionary meaning of crop. Here standing crop means the amount of energy which is in every tropics. amount of energy which is there in every tropics. So don't go with the dictionary meaning. So crop means the amount of energy which is seen in that particular tropics. We refer that as standing crops or amount of living crop. And this amount of living crop is something where the ecologists are concerned. So ecologists, they always compare the standing crop of each tropics. Ecologists, they compare the standing crop at each level. They compare the standing crop at each level. And when they compare the standing crop at each level, they found that at every stage, at every stage, at every stage, amount of energy which is consumed by the tropics, which we refer them as energy lost. At every stage, they found that 10% of energy is lost. At every stage, 10%, 10% of energy is transferred. 10% of energy is transferred from one level to another level. So it means 90% of energy is lost here. So that means 90% of energy is lost. Now, lost in the sense, remember, this energy is used by that particular tropics for their metabolic activities, respiration. And only 10% passes from one level to another level. So only 10% passes from one level to another level. And this 10% energy, which is passing from primary to secondary to the tertiary consumer, we refer this as ecological efficiency. Ecological efficiency. Or it is also referred as 10% rule. 10% rule. Is it clear? So this is what the flow of energy is seen. So it is always unidirectional, sequential, and once it is lost, it is always lost. It will never come back. It will never come back. Now, this is very significant to understand. If the total energy which is produced, if the total energy which is produced by the green plants, say it is 10,000 kilojoules of energy is produced, and out of this 10,000 kilojoules, only 10% is transferred here, right? So 1,000 units will be transferred here. And out of this 1,000, 90% is consumed by that level, and only 10% is transferred here. That is 100 units. 100 units. And out of that 100 units, 90 units are consumed by secondary part, and only 10% is transferred to the next. That is 10 units are there. So hence, only 10% is the energy which is transferred. And this 10% which is transferred is referred as ecological efficiency or 10% rule. Is it clear? So as there is a small amount of energy which is transferred, as there is only small amount of the energy which is transferred, so hence most of the ecosystems, we find the food chains will be at 3 stage or 4 stages only. So as there is very small amount of energy is transferred, as small amount of energy, that is 10% is transferred. So we find all the food chains are of 3 stages or the maximum 4 stages. So we find food chains, we have 3 stage or 4 stage, not beyond that. The reason is that we don't have sufficient energy to be consumed by the big species which can survive. So hence, only 10% is referred as ecological efficiency. So remember this part. They may ask why the food chain is only up to 3 stage or 4 stage. Why? Because only 10% of energy is transferred from one level to another level, and we refer that as ecological efficiency, from one level to another. Is that clear? And the terms are, the total energy which is produced is referred as gross primary production. Energy lost is R. Energy lost means energy which is consumed. And the energy which is always transferred is referred as net primary production. The amount of energy which is in each tropics, we refer that as amount of living material or standing crop. Energy in each tropics, we refer that as amount of living material or standing crop. And ecological efficiency, that is only 10% of energy is transferred. Only 10% of energy is transferred from one to next level. See, ecologists are concerned to read the ecological efficiency to understand that what is the amount of energy is transferred and what amount of energy is used by different type of the species here. Right. So this is what the two important perspectives, matter as well as energy. Now, when you're writing about the two things, always remember that in the context of ecosystem, the first one is matter. Matter is cyclic. It is recycled. The flow of matter is cyclic. That is, the role of decomposers plays an important role. They convert the organic part into inorganic, and this is recycled. So hence the flow of matter in ecosystem is always recycled. See, decomposers are not included in the food chain, so that is where we are having a drawback, right? Then if you see the energy, the flow of energy in the ecosystem is explained by two laws of thermodynamics. The energy can neither be created nor destroyed. It is transferred from primary to secondary to primary consumer to secondary to the tertiary consumers. Then the second one is that at every stage there is loss of energy. Right? And this energy flow is unidirectional, it is sequential. It moves from primary consumer to secondary consumer, then to the tertiary consumer. It moves from primary, secondary, and tertiary. And third, and very important, is that this flow of energy is never cyclic. It is, once it is flown, it flows. It is not cyclic. It is unidirectional or non-cyclic. It is lost. Once it is lost all the form. Is it clear? So remember these two characteristics. So the functions of ecosystem is matter as well as energy. Right. Now at this stage we can define the ecosystem. It is where a community or living organisms that live and interact with their specific environment. It is a functional unit of biosphere. It is flexible and it is open system. So hence we say it is a functional unit composed of living and non-living components which interact with each other. And here interact means flow of energy and nutrients. Flow of energy and nutrients. Now these ecosystems, they can be forest ecosystems, they can be pond ecosystems, they can be rivers, they can be lakes, they can be agriculture field, etc. Right? So all these are referred as the ecosystems, functional units. Now if you see all the ecosystems are in degraded conditions. So they all are in the degraded conditions because of over exploitation. And hence united nations United Nations has decided that why don't we create an awareness and restore the ecosystem. To create awareness and restore the ecosystem so that they can benefit the human beings. So 2021 to 2030 is classified as the decade of ecosystem restoration by United Nations. So United Nations has declared this 2021 to 2030 as the decade of ecosystem restoration. So once we complete this entire concept of ecosystem, then we will see the why the ecosystems are important. Non-cyclic means that they are, once they are lost forever. They will never come back into ecosystems. See, when we talk about the standing crops, so standing crops or amount of living material both are same. Standing crops or amount of living material both are same. And these standing crops or amount of living materials are found in the tropics. The energy which is stored in the tropics is referred as amount of living material. The energy which is stored there is called as standing crop or amount of living material. And the energy which is transferred from one to next, the energy which is transferred from one level to next level, that is hardly 10% which is transferred. And that 10% of energy which is transferred is referred as ecological efficiency. They degrade due to over exploitation. They degrade due to over exploitation, maybe due to a rapid urbanization, population increase, etc. Right? Now, food chains. Generally, we have two types of food chains. One is grazing food chain, and the detrital food chain. So, grazing food chain is the food chain which starts from a living plant. It starts from living plant. Living plants. So the green plants will produce the energy by photosynthesis. Then it is eaten by primary consumer, secondary consumer, and tertiary consumer. Right. So when they die, they are acted upon by decomposers. Right. So this flow of energy from producer to primary consumer, secondary and tertiary, where it starts from living plant, we refer that as the grazing food chain. Now there are many food chains which starts from dead organic material. They start from dead organic material, like dead plants, dead leaves, or dead animals. So if it starts from the dead organic content, then we refer that as a detroidal food chain. If it starts from dead organic part, dead leaves, which are eaten by wood louse, and then they are eaten by the blackbird. So this is an example of detrital food chain. Example of detrital food chain. Dead organic stuff eaten by wood louse, then eaten by the blackbird. Primary consumer, secondary consumer. So one is grazing food chain and second one is detrital. Two types of food chains are there. Now remember, food chain explains the flow of energy and sequence of eating and being eaten up. So food chain always explains the flow of energy flow of energy, and the sequence of eating and being eaten up. Eating or eaten up. Eaten up. Right. So here, primary and secondary. Now, once we know the food chain, along with the food chain, we also have one concept which is referred as food web. Food web. Now, what is difference between food chain and food web? Now, food chain is linear. Food chain is simple, or it is linear. Linear means straight line. Simple or linear. Now, always remember, food chain and food web both are the same characteristics. They explain the flow of energy. Food chain and food web both explains flow of energy, and also the eating and being eaten up aspect. Animals which eat and being eaten up. Eating or being eaten up. Being eaten up. So food chain is simple and linear. Now take any ecosystem A. So this is an ecosystem A. Now in this ecosystem, we have grasses, primary producers, and then grasses are eaten by the rabbit, and this rabbit is eaten by the hawk. So this is primary consumer, and this is secondary consumer. Now in the food chain, if the number of rabbits decreases, if the rabbit numbers decreases, then it will ultimately lead to decrease in the number of hawks because of the scarcity of food. It will lead to decrease in the numbers of the hawk. So in the food chain, if any one species is affected, then the next higher species is also affected by that. If the primary consumers are less in numbers, then it will affect the secondary consumers. The shortage of food will be there. And hence the number of hawks will reduce if it is linear, if it is simple or linear food chain. Now, consider another ecosystem. This is ecosystem B. Now, in this ecosystem B, we have grasses which are primary producers. And then we are having the rabbits, grasshoppers, mouse. Now, if the number of rabbits decreases, what happens? Now, here we find that the simple food chain has become very complex. It has become very complex. Right? And if the number of rabbits decreases, then the number of hawks will not decrease. Why? Because it will eat up the mouse, or it will eat up the grasshopper, or it will eat up the lizards. So when the food chain becomes complex, then it provides alternate arrangement for the foods. It provides alternate arrangement for possible maintenance of stability of ecosystem. Alternate arrangement for maintaining the stability of ecosystem. And this food chain, when it becomes complex, we refer that as food web. When the food chain becomes complex, we refer that as food web. So remember, food chain is a linear, straight line. When the food chain becomes complex, alternate arrangements are there for the next hierarchy, for the next higher organisms, for the next tropical structures. then we refer that as food web. So even if the number of mouse decreases, then the hawk can eat the snake and lizard and it can survive. So it always provide alternate arrangement for the stability of ecosystem. And hence food chain and food webs both provides the characteristics of flow of energy. And when the food chain becomes complex, we refer that as food web, which provides alternate arrangement for stability of ecosystem. Right. Now, bioaccumulation and biomagnification. Now, generally, when we talk about the energy which is entering, the consumption which is there, the primary consumers, when they consume the food, there is possibility that the pollutants can also enter into the food chains. So both talks about the pollutants which are entering into the food chain. Right. Now, when the pollutant enters in the first stage, that is in the primary consumers, it accumulates in the first species only. We refer that as bioaccumulation. Understand? Bioaccumulation. So in the bioaccumulation, the pollutant enters into the first stage. It enters into primary consumers. In the first level only. It enters into first level only. We refer that as bioaccumulation, accumulation of the pollutant. Accumulation of the pollutant. In the first stage, we refer that as bioaccumulation. Now, this primary consumer is eaten by the secondary consumers and the tertiary consumers. So there, the pollutants are transferred from one level to another level. So when the pollutants are transferred from one level to higher level, when they consume these pollutants, when they consume the species of the lower level, so this transfers from one level to another level. And not only it is transferring from one level to another level, it increases in the concentration. So this is primary producer, primary consumer. 10 primary consumers are there which are consumed the pollutant, and they are eaten by a big fish, shark. So it means that its concentration increases. When it is eaten by another big species, then it increases in the concentration there. So it increases from one level to higher level. Along with that, it is increasing in the concentration. Increasing the concentration of pollutant. We refer that as biomagnification, increasing in the concentration of pollutant in the higher organisms. We refer that as biomagnification. Now, all pollutants cannot make biomagnification. It is done by only characteristics of the pollutants. It is when the pollutant has long life. Second, this pollutant is soluble in the fats, mix up with the fats of animals, soluble in fats. Third one is that it's biologically active throughout its journey. It is biologically active. So these three characteristics makes the pollutants to move from primary consumer to secondary consumer to the tertiary consumers, which move from one level to another level by which it is increasing its concentration in the species of the next hierarchy. And this process, we refer that as biomagnification. Biomagnification. Right. So bioaccumulation means entering in the first stage, that is primary consumer. So if any pollutants are there, it is eaten by the primary consumers, and the pollution which is spread in the primary consumers first level, we refer that as bioaccumulation. When this primary consumer, which is already eaten up the pollutants, if it is eaten by the next hierarchy, secondary consumer, then the tertiary consumer, then the pollutants will move, they transfer from primary consumer to secondary consumer to the tertiary consumers, and we refer that as biomagnification, where the pollutants are not only transferring, they are not only transferred from one level to another level, they are increasing in the concentration as they move from one level to another level. So they increase their concentration also. They increase their concentration also. And this is what we refer that as the bioaccumulation and biomagnification. So remember, bioaccumulation means the pollutants which are entering into the ecosystem at first stage, that is primary consumers, like thousands of fish in the aquatic ecosystem. When they are affected by the pollutants, we refer that as bioaccumulation. And these fish, when they are eaten by the big fish, then the pollutants are transferred with increasing in the concentration, and we refer that as biomagnification. Is it clear? So bioaccumulation and biomagnification. Now what happens when the bioaccumulation and biomagnifications are there? So these bioaccumulation and biomagnification, they will always create threat to the organisms. They always create threat to the organisms in the form of disease, or it can lead to death of organisms. Threat which can lead to death or disease of organisms which consume them. So remember, bioaccumulation and biomagnification are two entities, are responsible for death of particular organisms which consume them, or they will create a disease, severe disease in that particular species or organisms which have consumed the pollutants. So hence the pollutants entering into the food chain or ecosystems at the first level is bioaccumulation, moving from one level to another level with increasing in the concentration. We refer that as biomagnification. Biomagnification. Is it clear? Now, a very classical example of this is seen in the context of vultures. The example of biomagnification and bioaccumulation was seen in vulture. Right. Now, this is seen in the northwestern part of India, Punjab region, Gujarat region, and some places of Pakistan. So there, large amount of cattle were there. Cattles. And these cattles, they had large amount of some problem was there. So they had a problem, and to treat the cattle from their injuries or from pain, right? So they used a drug called as diclofenac. Diclofenac drug was used as a painkiller to the cattle. And this diclofenac drug, when they are used by the cattle, it is non-biodegradable pollutant. Non-biodegradable pollutant. Now, this diclofenac did not decomposes, or it will not decompose when the animal dies. After the death of cattle, so remember, diclofenac drug is used to relieve the cattle from pains. Relieve the cattle from pains, painkillers, diclofenac drug. Now, when the cattle die, their carcasses, dead remains of the cattle, there they consist of diclofenac. So the carcasses consist of diclofenac, non-biodegradable or undecomposed diclofenac. And this diclofenac enters into the next hierarchy when the vultures, the detrivores, scavengers, when the vultures consume the carcasses, then the diclofenac entered into the digestive tract of vulture. So when the vultures consumed that, so this diclofenac entered into vulture. Now, what impact this diclofenac made on the vulture? So the concentration of diclofenac created renal disease in the vultures. So it created renal disease. Renal disease, that is kidney failure. Renal disease or kidney failure. Kidney failure. And this kidney failure or renal disease is responsible for large amount of death of the vultures. It leads to large number of death of vultures because of the diclofenac which entered from cattle to the carcasses to the vultures. Renal disease, kidney failure, and that lead to remove around 98 to 99% of the vultures. Now in India, we have 8 species of vultures are there. Out of these 8 species of vultures, three species of vultures, they are long-billed vulture, slender-billed vulture, and oriental white-backed vulture. Out of these 8 species, these 3 species, which have consumed the carcasses of the cattle, the diclofenac drug, they reduced their population of these 3 species to 98 to 99%, and the number reduced to so low that these three vulture species at present they are classified as critically endangered species. They are classified as critically endangered species according to IUCN, International Union for Conservation of Nature. So that is, if we don't protect them, then there is possibility that these 3 species of vulture will become extinct. So this is a classical example of bioaccumulation and biomagnification, right? Vulture and diclofenac drug. We see that quality of nutrients used by the plant's production is not good. Plants are injected when already 90% is lost and cannot due to, yes, we are having less, so that's why we say large amount of energy. It's not only us, at every level the energy is lost. And apart from that, when you talk about the energy which is lost there, apart from that, the nutrient lost and other things are also there which are linked with other factors. I'm just talking about the flow of energy, right? So this is what we say. Don't confuse that with accumulation. Bioaccumulation is different, biomagnification is different. So once we complete a major section of ecology, then the topics will clear. You can't decide any one content or any one concept based on only one discussion. So many factors contribute to that, many contributes to that, right? So this is what we refer that as the first example of bioaccumulation and biomagnification. Now, vulture and diclofenac. Has Indian government has done anything to protect this? Yes, we find that. The steps taken by government is the first national vulture plan, which was in the year 2006, where they have classified the diclofenac as Schedule H. Now, what is Schedule H? Schedule H means Schedule H means these diclofenac should be sold only on prescription. Diclofenac should be sold only against description. So we refer that as, it means strict action is done. Strict action was done. So any pharmacy who is keeping the diclofenac, so if it is prescribed by a veterinary doctor, then only he can give the diclofenac, only based on prescription. But in spite of that, there was misuse of diclofenac, which was continuously used. And in spite of classifying that as schedule H, the number of the vultures, they keep on decreasing. And ultimately, the second national vulture conservation plan was initiated in the year 2020 up to 2025. The first step taken by that is burning of the carcasses. So if you burn the carcasses, then there will not be any type of diclofenac fed body which can be consumed by the primary consumer. Then plan to consider the diclofenac in schedule X of the drugs and all. Now here schedule X, it talks about two things. He should keep the prescription for 2 years. He should make sure that whatever the diclofenac he is selling with prescription. Prescription is required. And second one is, he should keep the data to whom it has been sold for 2 years. He should keep the data for at least 2 years. 2 years to whom it is sold and what quantity of, to whom it is sold and what quantity it is sold, so that strict regulation was done in the context of diclofenac at this particular vulture. And one safe zone for each vultures by 2025, and setting up of 8 more vulture conservation breeding up to 2025. The reason is vultures are having very low fertility rates. Vultures have very low fertility rates. It means that their birth rates are very, very less until and unless we make a proper conservation of that. So because of that, we need to increase more vulnerable, we need to increase more vulture conservation breeding centers by 2025. And government is planning to set up at UP, Tripura, Maharashtra, Karnataka, and Tamil Nadu. New 8 more in these, as the fertility rate of vulture is very, very less here. And these are the areas where they are existing. These are existing breeding centers. We find in Assam, we find in Jharkhand, West Bengal. So government is planning to increase to another 8 areas. Why? Because vulture has very low fertility rates. Vulture has very low fertility rates. Is it clear? So this is some rough idea about bioaccumulation and biomagnification. Right. You have to remember the facts. Which are very important for your mains. Now, how it increases? It will increase. See, in the primary consumers, 100 fish are there who have consumed this pollutant. Now, out of these 100 fish, say king mackerel has eaten around 20 fish. So every 20 fish will have its own composition of pollutants. So when it eats all the contaminated 10 fishes, then all the 10 fishes volume of pollutant enters into the king mackerel. So hence the concentration of the pollutant increases in the king mackerel compared to the primary consumers. So 3-4 king mackerels are there which have eaten all these 100 fish, and these king mackerels are eaten by some big fish. Then when all the 3 are eaten by big fish, then the concentration of pollutant increases in that big fish which is consuming them. So that's why generally when you visit in the hospitals, generally the doctors say that the pregnant woman should not eat kingfish or mackerel fish. Generally they say avoid kingfish or mackerel fish. Why? Because there is possibility that they may have higher concentration of the pollutants which have entered into the food chain. So this is how it increases. So the 100 fish which have taken the pollutant, we refer that as bioaccumulation. And these 100, out of that 50 are eaten, then again it is moving. So there it is increasing in the concentration in the in the hierarchy. So when the pollutants are reaching from one trophic level to second level with increasing in their concentration, we refer that as biomagnification or bioamplification. Another name for biomagnification is bioamplification. Amplification. Is it clear? Okay. Critically endangered species will take up when I take biodiversity. It is defined by International Union for Conservation of Nature, state of the plants and animals, IUCN, where it talks about state, present state of that, present state. So whether they are more in numbers or less in numbers. So the moment when it is a critically endangered, it means that their numbers have shrunk to very low, and you have to maintain a proper conservation or else they will become extinct. Okay, so we'll end up the class here. So tomorrow we'll continue from where we have left. Right now, regarding the notes, don't get much stress. You keep the PPT as a reference, and wherever I have mentioned them, you make the notes of that and read your NCERT class 12th and link that with updated current affairs. So this is the first class. Don't get much stress. So over a period of a time, so when 4 or 5 classes are complete, then I'll tell you that how to make up that. Don't get much stress. So whatever I'm telling through the PPTs, they are more than sufficient for you to have the basics. Only thing is you should update with current affairs, the new updations which have been seen in the updations in the technologies or usages. So over a period of a time, when we move on to another 5 days, 6 days down, you will understand that how the current affairs are linked with this discussion. Is it clear? So don't get much stress. We will make sure that the things are simple to be remembered. So till tomorrow, take care. Right, so we'll make the flow. So don't think about any such book. I've taken this from many references, so if you keep the PPT as references, that is sufficient. NCERT class 12th last 4 chapters will give you certain basics. So once we complete a good number of topics, then I'll tell you from where you have to pick, because now if I name anything, it becomes very difficult for you to digest. So take care. We'll meet up tomorrow at the same time.